Okay, hi grade 10s. This is the very last little bit where we're going to look at summarizing what the image looks like in a plane mirror and how to describe that image using characteristics, okay, like the size of the image, what's called the attitude of the image, etc. All right, so let's just reflect and review on the law of reflection. Remember, the incident ray is the light that travels towards the mirror. The reflected ray is the light that travels away from the mirror. The normal is an imaginary line drawn perpendicular, right angle to the mirror. What does the law of reflection state? It states that the angle of incidence, okay, that is theta I, is equal to the angle of reflection. Oops, sorry. And that would be theta R. Okay, so if we were to draw that on our diagram right here, I want you to summarize. I don't want you to be able to just draw this. Use a ruler, draw your mirror. You've got the reflected surface on the top. At the back is the opaque part where you've got the hashtag, the hashes at the side. I want you to take your ruler and I want you to draw a line that is straight down. Okay, that is the normal. I'm just going to erase it and actually use a dash, but I would like you to use your ruler. Okay, that is your normal. Now let's take a different color and let's show what an angle of incidence would be. It's going to hit the mirror exactly at what we call the normal. Okay, so here we go. This is the incident ray. The angle here is the angle of incidence, and I would use my protractor and actually measure this, although I'm just going to eyeball it because I don't have a protractor I can put right on my iPad. This is the reflected ray, and the only way I can tell that on the diagram is if you put arrowheads on there. You have to be able to put an arrowhead so I can see that this is the light going in, this is the light that bounces off or reflects. Okay, the angle of incidence equals the angle of reflection. That angle is between the incident ray and the normal, and between the reflected ray and the normal, not the other way around. Okay, all right. Now, once I have that established, I reviewed my reflection, law of reflection. I want to look at what the characteristics are of an image that I look at in the mirror. Okay, so we use two terms. We've been using them for the last hour or so, right? An object is simply the item in front of the mirror. And the image is the object or the reflected item. And we can describe that image in terms of an acronym called SALT, okay? The S stands for the size of the image. The A stands for a word called attitude. Attitude means is the image that I see when I look in the mirror, is it upright or is it inverted? Is it right side up or is it upside down? The physics terms we use are we're describing its attitude. Is it upright or does the image in the mirror look inverted? The L stands for location. This is how far away from the mirror is the image, okay? Is it closer? Is it farther away? Is it in front of or is it behind? The T is the type of image that it is, and if we are looking at an image in a plain flat mirror, it is always going to be a virtual image because it is always an image captured behind the mirror and you can't capture it in front of the mirror. Therefore, the word we use is always called virtual. Okay, so there's your acronym you're going to use to describe the image. We remembered from the last lesson that the distance of the image to the mirror is equal to the distance of the object in the mirror. So you can figure out where that image is going to be located if you take the object and do a few measurements from it. That's the easy way to do it. And in a second, I'm going to show you how to do it where it's a little bit trickier. Okay, here's the takeaway. Every single image that you see in a plane mirror is always the same size. It is always upright it is always behind the mirror, and it is always virtual. And those are the characteristics of an image in a plain flat mirror. Okay, it's going to change when we start looking at images in a curved mirror, but for today it's nice and easy. It's the same all the time. Okay, it's going to change once we have some curvature to it. Why? Why do we see this virtual image? Remember again, light travels in straight lines. Your brain assumes that the rays are also traveling straight. It sees the object where it should be, not that it's really there, and that's the term that we say a virtual image. How do you do this? Okay, there's some instructions here in the note. Feel free to follow along in the textbook. There's a video that goes along with this that I want you to watch because it's an animation where he can show you, Mr. Anderson can show you what it looks like. But this is essentially how you would do it, okay? You would set up your eyeball right here. Here's my object. Here's my plain flat mirror. I could just simply measure the distance between the top of the object and the mirror and figure out where the image is behind it. Same at the bottom. Or you can do this. You can take a ray of light from the tip top of my object. In this case, it's an arrow instead of a pen. Okay, make it fancy. Take your ruler, draw a incident ray going towards the plane mirror. Use your protractor. You know that the angle of incidence, which on this diagram right here would be from here to here, wherever the normal is, right, is going to equal to the angle of reflection. You're going to draw the straight line down to your eye. Then you take a ray coming from the bottom of your object, straight line towards the mirror because light travels in straight lines. Figure out the angle of incidence and the angle of reflection because down here where this light ray meets, there's your normal. The angle is equal to the angle. Draw that reflected ray back to your eye. Okay, so incident ray, reflected ray, incident ray, reflected ray, and I know that because I put arrows on them. Then look what you do. You take the reflected rays. Can you see the two reflected rays? Let me get rid of this for a second. Okay, that's where we're headed with this. You take the reflected ray here, you use your ruler, project it back behind the mirror. You take the reflected ray from here, okay, behind the mirror. If you did it two objects, if you had two lines going from each spot, it gets tad messy there. But essentially what you would do is you can then draw the image over here, but then you remember that every time you draw a line behind a mirror, it's not a straight line. It is a dashed line, okay? So I'm going to erase my image for a second. And I'm going to show my image with a dashed line, whereas my object was the full line, okay? So in summary, when reflected light off a plane mirror enters your eye, your brain projects these rays behind in the form of an apparent light source behind the mirror. A virtual image is formed by the apparent light source because no light rays are actually arriving at or coming from the image location. A plane mirror divides the object image line in half and is perpendicular to the line. The acronym SALT for size, attitude, location, and type can be used to remember the four image characteristics, and an image in a plane mirror is always the same as the object upright, behind the mirror, and virtual. And that's it for light and plane mirrors. Next time we'll look at the curved mirrors, and it's quite a bit of fun too. Okay, good luck.